There's a lot of mathematics that needs to be developed to be able to verify the way that certain models work, to do things like, for example, knowing what, I'll do a little bit of statistics speak here, knowing what the error bars look like on the input to these models, being able to follow that through the model and figure out what the error bars are going to look like coming out the far end. That's kind of an interesting subject, and it's a hard one. But if we can do that, then we can figure out how much trust to place in those models. Contrary to what a lot of people believe, those models have done a marvelous job, actually, historically, of predicting what's going to happen. And, we're looking back in the past. There's a classic case in the 90s where the oceanographers went out and got some measurements off the ocean floor and came back and said, this is in total, this is in total violation, total contrast to what the models are telling us. And the modelers looked and looked, and they tried to figure out what was wrong with their models and never could. Turned out it was because the oceanographers had misevaluated their data. So the models have been pretty solid, but they could still use improvement. As I think it was actually Niels Bohr who said, though it's been attributed to Casey Stengel, it was Niels Bohr who said the prediction is very difficult, especially of the future. So the models are designed to help predict the future, and that's something that mathematicians could really help with and have not been involved enough with. But there's a lot of other opportunities to be involved with mathematics too, and climate science, such as the mathematics of social science. There are a lot of societal decisions that are going to have to be made that are based on how much you're willing to discount future harm. It's the same problem you run into in calculus too when you're talking about the present value of an investment that you're going to cash out in the future. It turns out to be the same problem, but it has a tremendous application, and a very controversial application, actually, to climate science, because in deciding what we have to do right now, we have to be able to decide what those discount rates are that we're going to be placing on future harm, and those tend to be somebody's opinion as much as anything. It would be helpful if mathematicians could help a little bit with getting a little bit of stability in that particular problem too. So there's lots of opportunities out there, and that's an area I think is really exciting that students should think about getting involved in. It's, again, you sort of feel like you're dealing with the parameters for the end of the world, but there is still a lot of time to do a lot of things about this.